Hi, welcome to the next in the series of H4 plugins talking about GPIO. Today we're looking at filtering and debouncing. So first, filtering. Let's have a look at what we have up here. We've got an extra parameter now at the end here, and a filtered input is like a raw input, but it only passes through either high transitions or low transitions depending on what you put in that final parameter. So it doesn't have any debouncing done on it as such. So if you've got a bouncy switch and you press it, you're going to get a series of transitions, but only one sort will get passed through. So if you've ever done any interrupt processing, this is like selecting rising edge or falling edge of an interrupt, as opposed to change where you get both signals. So without further ado, the rest of the code is the same. So let's look at what happens. You should be able to predict this now. The very first time I hit the button, it's going to pass through a logical 1, which we then pass to the LED. So we're going to set the LED to red, and then from that point onwards, only thing we're ever going to send it is 1s. So it's always going to stay on. So here we go, proof is in the pudding. There we go. And no matter what else we do now, it will stay on. But can you see also the bounce happening still? Let me just clear that out. Just watch carefully in the serial window. I'll try and make it more obvious. There we go. Look, one press and 1, 2, 3, 4, 5 bounces. One press, 1, 2, 3, 4, 5 bounces again. 2 bounces. No bounces at all. Isn't bouncing fun? Right, bouncing isn't fun, it's not very useful, and it usually needs to be removed. So we're going to look now at how to remove bounce. Let's move to, first of all, we'll clear that, then we will move to the debouncing sketch. And I have to compile that into the testing, but while we do that compilation, we're going to look at some useful additional things, because I've changed the way that we've got the programming style here. See now that we have a global event handler. Oh, I've done that bad thing again. It's really not very helpful, is it? I'm sorry. We've got the global event handler, which will actually catch every single event of any kind in the program. And what we've done is we've stuck into the middle of it this thing here, which we call a function adapter. And that says, of all the events that come through here, when you get one that says GPIO on it, expect there to be a function somewhere in the program called on GPIO, and that's what you need to call when you get the GPIO event. And rather cleverly, it also converts the pin number and its value for you. So all you have to do in your own handler routine here is deal with whatever pin you're dealing with. Now we know we're dealing with pin 0. That's the only pin we've got, so we don't need to do any switch or complicated stuff in there. But the reason that I've introduced that at this stage is because this global event handler function is going to be in a lot of sketches, because once we start getting into sketches where we need to deal with more than one event type, we can't just have a single event handling function. We have to have an event handler function that does everything and then pick out the bits we need and point them to the relevant places. And that's what happens here with our difference in programming style. So we have now compiled our debounced switch, but there's something else that I just want to bring up before we go into the code itself. Now then, if you look here, we've got all the things we normally would have, but then we've got this extra value here. Look, 50. What does that mean? That's 50 milliseconds. And if you look on the chart there of what a bounce looks like, it's the amount of time that we're going to wait for a steady state before we declare that the event has happened. Now then, that obviously means that there's going to be a slight lag of at least 50 milliseconds in this case between me pressing the button and the signal getting passed through to the LED. And the idea of debouncing things like this is to have that as low as possible so that we get the least amount of lag and the most effective response to the press, but big enough so that you're never going to get an accidental double press or flicker or bounce. So let's start with 50. Now watch the serial window as well again. Here I go. I'm going to press the button. Why does this never like to do this for me? Let's try that again. There we go. You'll see there that pin 0 is the button, pin 12 is the LED. Now, because we have got the global event handler, we're getting both sets of pin messages coming through. So it's very useful to see how that works. We get a single 1 transition, which we then pass to pin 12 to light the LED. Then we get a single 0 transition, which we then send to the LED to put it off. So once again, we press, we get a 1, and we get only a 1. The bounce has gone, look. And then when we let go, pin returns to 0. We pass 0 to the LED. On, off. Now then, I love it when things like this happen. Never work with animals or do anything live. This button is so bouncy that unless you press it really, really hard, it can kind of wiggle and wobble and switch on and off again. So if you just stab it, not a problem. But if you can do that with it. That's actually turning it on and off. That's not bounce. That's the button actually turning on and off. So I'm going to have to try and be careful with that. So you can see that normal, nice, slow, positive press, we got no bounce anymore. Now what I'm going to do is I'm going to take that down to, I'm going to take it down to 15, recompile the code and see how much difference that makes. So let's get rid of that little bounce window first. Let's clear our COM window and let's see whether with this switch we can get away with 15 milliseconds of bounce, because if we can, the button's going to be much more responsive. Alrighty, we're almost done. So if anybody likes to gamble, they can put their money on whether this is going to eliminate the bounce at 15 milliseconds if they want to. It's my button. I've played with it before. I'm not putting any money on it. These buttons are horrible. Seriously, they're They're off eBay. They're the cheapest ones you can get, and they are bouncier than a trampoline thing. Right, okay, let's try it. Oh, not bad. Not bad. Not bad. Oh, actually, it's behaving again. So, unfortunately, live demos always happens. I'm going to take it down to 5 milliseconds now, and this is going to bounce. I swear it will. And if it doesn't, well, we've all had a bit of fun and a bit of a laugh, haven't we? But I hope you understand the principle. We wait for a given amount of time while ever a steady state remains. And once that time's elapsed, we then say, okay, that transition has been made, all the bouncing's finished, now have the new value. So whether it's active high or active low, it doesn't matter. When it changes from one state to another and then goes boing, 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 we internally start a timer. And then once it's gone boing in the opposite direction from where it started from, and that timer is elapsed and it's still boing in the opposite direction, we then send the event to say you've had a change. Right, we've got 5 milliseconds on the bounce now, on the debounce. Let's see if this is going to behave, and I'm going to try my best to actually make it bounce, just so that you can see that debouncing isn't magic. It depends on the amount of time that you put in there, and that value is different for every type of switch. In fact, it can be different for 2 switches of the same type from the same batch. So you need to experiment, have a play, and find out which is really which. So here we go. Let's try. No, it's behaving. Oh dear, I love it when this happens. Okay, look, I've got a switch that gets away with only 5 milliseconds of debouncing. Right, come on. No. So every change now, you should see 4 messages. One of the downstroke and the LED, one for the upstroke and the LED. So if you see any more than 4, it's a bounce. No, 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 no. Well, look, I'm not going to waste any more of anybody's time. You can see that the debouncing works even with very low values. That's about it for this video. Look forward to making the next one for you. Do all of the YouTubey things, you know, like the video, subscribe to the channel and click the bell notification icon, because here's the thing that other channels don't tell you. Every time you don't do all of those things, a chip lets out the blue smoke somewhere.